Hello guys, I hope you are enjoying my videos. Today we have the topic of physics, which is about Coulomb's law. So let's start our topic of the day. So according to definition or statement of Coulomb's law, the force of attraction or repulsion between two point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So, according to this definition, force of attraction or repulsion between two point charges is directly proportional to the product of the magnitude of the charges. It means that if you increase the magnitude of charges, so the force of attraction or repulsion will increase, and if you reduce the magnitude of the charges, then the force of attraction or repulsion will decrease. And the second part of the law, and inversely proportional to the square of the distance between them. So it means that if you decrease the distance between the charges, so force of attraction will increase, and if you increase the distance between the charges, so the force of attraction will decrease. Directly proportional means that if you increase one value, the other value will also increase. And inversely proportional means that if you increase one value, the other value will be decrease. So in mathematical form, we can say F is equal to K into Q1 Q2 divided by R square, as per definition of the Coulomb's law. So here F is electrostatic force in Newton. The unit of force is Newton. Q1 and Q2 magnitude of the two charges. So this Q1 and Q2 represents the magnitude, that is the value of these charges in coulombs. C means coulombs. Coulomb is the unit of charge or distance between charges in meter. So as you know that the SI unit, System International Unit of distance, is meter, and R is the distance between these two charges. K is a Coulomb's constant, which is equal to 9 into 10 raised to the power of 9 Newton meter square per Coulomb square. So this is the unit of K. If you forget this value, you can also derive this unit from this formula if you remember this formula. How? For example, K will be equal to F divided by Q1, Q2 and multiply by R square. So K is equal to F R square divided by Q1, Q2. So F is Newton, and when you multiply R over here R square, so it will become Newton meter square, and this will come here in division. So this will become Coulomb square. So Newton meter square divided by Coulomb square. Newton meter square divided by Coulomb square. So if you forget this value of K, this unit of K basically, so you can derive this unit from here as well. So let's move forward. Nature of force. So like charge is both positive or both negative repulsive force. If both the charges are positive, they will repel each other, and if both the charges are negative, they will repel each other. Similarly, unlike charges, that is, one charge is positive and one is negative, so they will attract each other. So attractive force. Now let's derive the Coulomb's law step by step. So let's two charges Q1 and Q2 be placed at a distance R. So from experiments and as per definition of and statement of Coulomb's law, if, that is, force of attraction or repulsion is directly proportional to the magnitude of the product of these two charges. So F is directly proportional to Q1 and Q2, this is sign of proportionality. This is called sign of proportionality. So F is directly proportional to Q1, Q2, and similarly F is inversely proportional to the square of the distance. So if we combine these two relationships, so we will get a single relationship or a single relation as F is equal to Q1, Q2 and this divided by R square. So when we remove this sign of proportionality, so we introduce is equal to constant. So we will put here is equal to constant. K is a constant. So F is equal to K Q1 Q2 divided by R square, and this is the mathematical form of Coulomb's law. That is important notes, some important notes. Coulomb's law only valid only for point charges, and charges must be stationary, that is in static form, and work best in vacuum or air. If there is a vacuum or there is air as a medium, so Coulomb's law will work best. So based on experimental result by Coulomb using torsion balance. So these are important notes for applying Coulomb's law. So this was all about the Coulomb's law. Thank you for watching. If you have any kind of question, you can ask me in comment section. Okay, take care. Bye bye.